If you are looking for some support for current affairs, if you are a fresher, you are a working professional, you are a repeater, but you want some support for current affairs, then I have a program for you. I have given the brochure and also the announcement video link in the description. You can watch if you are interested. Hello all, welcome back to Current Affairs Hitlist series. I am Guna Mathivanan from Office's IAS Academy. In today's video, we are going to discuss about Nobel Prize for Chemistry. Nobel Prize for Chemistry was given for the discovery and synthesis of quantum dots. So what is quantum dots? For understanding quantum dots, let me take an example. Now you take gold. You take a piece of gold, 1 kg gold bar. You are taking 1 kg gold bar. That gold bar will be yellow in color. That is going to be yellow in color. Now I divide that gold bar into two. 500 grams, 500 grams. Again, both will be having yellow color. Now I divide that further. 250 grams, 250 grams, 250 grams, 250 grams. Everything is going to be yellow in color. Now assume I am dividing it further. Now I am dividing into gram. Now I take 1 gram of gold. That 1 gram of gold, that will also be yellow in color, no doubt. But if I further divide that gold, now 1 gram, I am dividing into 1 milligram. I am dividing. I am going to the order of nanoscale. So we know I am dividing 1 by 1000, that is going to be milliscale. That milliscale I am going to divide by 1000, that is going to be microscale. That I am going to divide it by 1000, I will be getting nanoscale. 10 to the power of minus 9 nanoscale. Right? Our human cells will be of that nanoscale. Imagine I am dividing the gold into such a smaller piece. At that time, what happens is the glowing properties of these substances gets varied. So when it was 1 kg, gold was yellow. When it was 500 grams, gold was yellow. 250 grams, gold was yellow. 1 gram, the gold was yellow. But when I am dividing the gold into the nanometer scale, in nanometer scale, I am dividing, breaking down. Let's say, for example, I am dividing it into 20 nanometers. Now, the gold is having not yellow color, orange color. Assume I am having 30 nanometers gold. Now, that is having green color. I am having 40 nanometers gold. Size I am reducing it, right? So, I am getting, let us say, brown color. I am getting brown color. Be 50 nanometers. I am getting blue color. So, the point here is any substance, when you are dividing it in nanometer scales, when it goes to nanometer scales, 1 kg gold dividing into 1 gram, that is fine. But 1 gram you are dividing into milligram, that you are dividing into micro, that you are dividing into nano. When you go to the nanoscale range, the glowing property, the coloring property, the glowing property of the substances, that is going to change based on the size. When the size varies, the glowing property varies. It will not be in yellow color. Right? That is called as quantum dot. Sir, why it happens, sir? See, when you are reducing the size of the matter in nanometer scale, that matter here refers to gold. When I reduce the size of the gold to that nanometer scale, the gold size is so small, the electrons inside the atom of the gold is made up of atoms. That atom has electrons. At nanometer scale, the electron space is limited. 1 kg of gold means, imagine the gold atoms, electrons, they'll be moving. They have a lot of space to move. At nanometer scale, the movement of electrons are restricted because of the smaller size. So the properties of these electrons, their behavior at that level is different. At that level is different. Right? We discussed about quantum computing in the previous classes. What is the quantum physics? What is physics? The classical physics studies the laws of nature. What is quantum physics? The physics laws which we know that may not be true at subatomic level. Inside the atom, there is a whole new world. In that world, we see electrons, protons, neutrons, etc. These reactions may not obey the laws of classical physics. See, we are affected by gravitational force. Okay, inside the atom, the force which governs in the behavior of the electrons, protons, neutrons will be different. It can be different. So at nanometer scale, these electrons will be behaving in a different manner that results in release of different glowing properties. That is called as quantum dot. So what happened is, so if I am not wrong, it should be Ekimov or Bruce. I'll just share a small story. The story is Mr. Bavendi. So he was doing chemistry PhD in Harvard. So he went to Bell Laboratory to do some internship. In the Bell Laboratory, so I'm not sure whether it is Bruce or Ekimov, right? I assume Ekimov. I think it is Ekimov, Alexei Ekimov. So this Bavendi met Alexei Ekimov, and Alexei Ekimov was conducting a research. Okay, in that research, Bavendi was going and helping. The research was originally not about quantum dot, it was of different thing. In a different procedure, they were able to discover the properties of quantum dots. So from there, quantum dot concept got evolved. Okay, so look at the applications of quantum dots. The quantum dots, see, we know about QLED TV, quantum dot LED TV, that is an application. So we will be getting finer colors. We will be getting finer colors of quantum dots, right? So in QLED TV, we are using this quantum dot technologies. In medical imaging, this quantum dots can be of more use. Imagine a patient is having cancer. A patient is having a cancer. Now you send medicines in the form of quantum dots, or using quantum dots, you develop medicines and you are sending it inside the patient. Now the quantum dot glowing property can go and identify the cancer cells, and around the cancer cells it can give some different kinds of glow. With that glow only we can find out where the cancer cell exactly is. We can do surgery or any other therapies using this medical imaging. So in the field of medical imaging, in the field of television technologies, these quantum dots will be having a lot of applications. So for development and synthesis of this quantum dots, Nobel Prize chemistry was given this year. So you got an idea what is quantum dot, you got an idea what is attosecond. Okay,